Scientists say they found human DNA from a fossil that's 400,000 years old. Until now, the oldest known DNA went back a mere 100,000 years old.
Deep within our own genetic code lies a secret from the Ice Age. Scientists thought they were just sequencing the DNA of an extinct species, the Neanderthals, to close a chapter on a primitive relative. But what they found was explosive, a connection so profound it changes everything we know about our own humanity. You see, they didn't just vanish, they became part of us. The evidence is undeniable, and it reveals a hidden chapter of our past so dramatic it will make you question the very story of who you are. A family secret. When the first draft of the Neanderthal genome was published in 2010, the scientific community and the world was stunned. The results were a bombshell that shattered a century of accepted dogma. The most shocking fact was this: Neanderthals had not just vanished without a trace, they had interbred with our direct ancestors, the modern humans who migrated out of Africa. The proof was right there, written in the DNA of billions of people alive today. Anyone with ancestry outside of sub-Saharan Africa carries between 1 and 4% Neanderthal DNA. Let that sink in. A species we thought was completely extinct lives on as a small but significant part of us. This discovery didn't just add a new chapter to the human story, it ripped up the whole book. The simple idea of Homo sapiens marching out of Africa and completely replacing all other hominins was proven wrong. Our history wasn't a clean sweep, it was a messy, complicated, and far more interesting affair. You see, when our ancestors left Africa around 60,000 years ago, they didn't enter an empty world. Eurasia was already home to other kinds of humans, including the Neanderthals, who had lived there for hundreds of thousands of years. And when they met, they didn't just compete, they connected. They had children together, and those children carried a mixed heritage that has been passed down to this very day. Believe it or not, this genetic inheritance isn't just a fun fact. It has real-world consequences. Scientists have linked these ancient genes to a whole range of traits in modern humans, from hair and skin color to the way our immune systems function. Some Neanderthal genes, for example, seem to have given our ancestors an advantage, helping them adapt to the colder climates and different diseases found outside of Africa. But not all things are what they seem, and this ancient legacy is a double-edged sword. Other Neanderthal variants have been linked to an increased risk for things like type 2 diabetes, Crohn's disease, and even depression. It's a powerful reminder that our evolutionary past is still actively shaping our present-day health. This revelation forces us to see Neanderthals in a completely new light. They weren't a separate, failed species. They were part of our story, a branch of the human family that was ultimately reabsorbed into our own. The line between us and them has been permanently blurred. They were so closely related to us that they could have children with our ancestors, and those children were healthy enough to pass on their genes through countless generations. This single discovery has launched a revolution in anthropology, opening up questions we never thought to ask. But the secrets of the Neanderthal genome were just getting started. Another shock was coming, when East met West. Before the genome was sequenced, we thought of Neanderthals as a single, uniform group of people primarily living in the caves of Europe. It was a simple, tidy picture. But the thing nobody tells you is that reality was way more complex. Genetic analysis from different Neanderthal remains found across Europe and Asia has revealed a hidden world of deep diversity. It turns out Neanderthals weren't one monolithic people. They were a sprawling network of distinct populations, separated by vast distances and thousands of years of history. The evidence points to at least two major distinct groups: a Western population centered in Europe and a separate Eastern population that lived thousands of miles away in Siberia. When scientists analyzed the DNA from remains found in Vindija Cave in Croatia and compared it to the DNA from a Neanderthal toe bone found in Denisova Cave in Siberia's Altai Mountains, they saw a clear split. These two groups had been separated for a very long time, possibly as long as 150,000 years. This deep division paints a picture of a species spread thinly across a massive continent. For long stretches of the Ice Age, these populations would have been completely isolated from each other. separated by impassable glaciers and harsh, frozen deserts. During these periods of isolation, they would have developed their own unique genetic signatures, like long-lost cousins developing different accents. But what's truly mind-blowing is that these groups didn't stay isolated forever. The Ice Age wasn't a constant frozen winter, it was a roller coaster of climate change. As the great ice sheets advanced and retreated, they opened and closed migration routes across Eurasia. And get this, Neanderthals used them. In another Siberian cave called Chagyrskaya, researchers found Neanderthal remains that told an astonishing story. Genetically, these individuals weren't closely related to the earlier Neanderthals from the nearby Denisova cave. Instead, their DNA was a near-perfect match for the Neanderthals in Europe over 2,000 miles away. This is incredible proof of a massive long-distance migration. A wave of European Neanderthals traveled all the way across Asia, eventually replacing the local Siberian population. We're talking about a journey that would be daunting even today, undertaken on foot through a harsh, prehistoric world. This completely changes our image of them as a static, homebound people. They were explorers and pioneers capable of epic journeys that reshaped their world. And you can see this everywhere in the genetic record. There wasn't just one migration, there were multiple waves of movement back and forth over tens of thousands of years. Europe and Asia were connected by a pulsing flow of Neanderthal populations, mixing, replacing, and exchanging genes in a dynamic dance dictated by the planet's climate. This constant shuffling means that a Neanderthal from France 500,000 years ago might have been genetically very different from one living in the same spot just 100,000 years later. This new dynamic picture helps explain some long-standing mysteries in the fossil record. For years, archaeologists had noted subtle differences in the tool technologies and physical features of Neanderthals from different regions. Now we know why. We weren't looking at one group, we were looking at a complex mosaic of populations with their own distinct histories. This makes the Neanderthal story not one of a single doomed lineage, but of a vast and resilient network of peoples who adapted and survived across half the globe for hundreds of thousands of years. But Neanderthals weren't the only ancient humans leaving their mark across this vast landscape. When three worlds met, just when the scientific world was reeling from the revelation that we all have a little Neanderthal in us, the story took another even stranger turn. In that same Siberian cave where eastern Neanderthals were found, Denisova Cave, archaeologists unearthed a tiny fragment of a finger bone. It belonged to a young girl. The bone was so small and unremarkable that it could have easily been overlooked. But when Svante Pääbo and his team sequenced its DNA, they were in for the shock of their lives. The genetic code didn't belong to a Neanderthal, and it wasn't from an early modern human. It was something entirely new, a previously unknown branch of the human family. They called these mysterious people the Denisovans, named after the cave where they were found. This discovery was like finding out you have a third set of grandparents you never knew existed. The thing nobody tells you is that for most of our evolutionary history, Earth was home to multiple species of humans living at the same time. The Denisovans were the Neanderthals' closest known relatives, having split from their lineage hundreds of thousands of years ago. But while Neanderthals primarily occupied Europe and Western Asia, the Denisovans seem to have been the masters of Eastern Asia. Their genetic legacy is found today primarily in the populations of Melanesia, Papua New Guinea, and Australia, with some people there carrying up to 6% Denisovan DNA. This suggests that the Denisovan range was enormous, stretching from the cold mountains of Siberia all the way down to the tropical islands of Southeast Asia. And here's where the story gets even crazier. Denisova Cave, it turns out, was a prehistoric crossroads. It's the only known place on Earth where we have found evidence of three different human groups: Neanderthals, Denisovans, and modern humans, all living at different times. But they didn't just share the same real estate, they also shared their genes. The team at Max Planck analyzed another bone fragment from the cave and found it belonged to a teenage girl who had lived around 90,000 years ago. Her DNA told an unbelievable story. Her mother was a Neanderthal and her father was a Denisovan. Nicknamed Denny, she is the first and only direct first-generation hybrid of two distinct human species ever found. This wasn't a guess or a theory, it was a direct snapshot of an encounter between two different worlds. This proves that interbreeding between different human groups wasn't a rare or accidental event. It was a fundamental part of our evolutionary story. The human family tree isn't a neat tree at all. It's more like a tangled, braided stream with channels constantly merging and splitting apart. The Denisovan genome, like the Neanderthal one, shows that these ancient encounters left a lasting mark. A specific Denisovan gene, for instance, is found in modern Tibetans and helps their bodies thrive in the low-oxygen environment of the high Himalayas. This is a clear example of how interbreeding provided our species with crucial genetic tools to adapt to new and challenging environments. The story of our past is a story of mixing, a great human melting pot that was bubbling away for hundreds of thousands of years before modern humans even became the dominant group on the planet. This raises the biggest question of all. If Neanderthals were so widespread and adaptable, why are they gone? When worlds collided. The final chapter of the Neanderthals is the most debated and, in many ways, the most tragic. For over 300,000 years, they had been the undisputed masters of Ice Age Eurasia. They survived extreme climate shifts, hunted massive and dangerous animals, and spread across a continent. And then, in a geological blink of an eye, they were gone. By about 40,000 years ago, their fossils and their distinct stone tools disappear from the archaeological record. For decades, the simple explanation was that our ancestors, the smarter and more sophisticated Homo sapiens, simply outcompeted them, driving them to extinction. But like everything else in this story, the truth revealed by DNA is far more nuanced. What many overlooked is that the Neanderthals' decline began long before modern humans arrived in Europe in large numbers. The genome of a Neanderthal from the Altai Mountains who lived around 120,000 years ago shows alarming signs of inbreeding. Her parents were very closely related, possibly half-siblings. This suggests that toward the end of their reign, many Neanderthal populations were becoming small, fragmented, and isolated. Living in tiny groups makes a population extremely vulnerable. Genetic diversity plummets, making them less able to adapt to new diseases or changing environments, and harmful mutations can become common. The relentless cycles of the Ice Age likely played a major role, with extreme cold snaps repeatedly shrinking their populations and forcing them into isolated pockets of survival. They were a species already on the ropes. Into this fragile world walked Homo sapiens. We didn't arrive as a conquering army. The most shocking fact is, our populations were initially quite small as well. But we had a few key advantages. While Neanderthals seemed to live in smaller, family-based groups, modern humans formed larger social networks. We traded tools and information over much wider areas. This cultural connectivity acted like an early version of the internet, allowing innovations to spread quickly and providing a safety net when local resources ran low. If one group was struggling, another could help them. This social resilience may have been our secret weapon. And then, of course, there was the interbreeding. As modern humans spread across Eurasia, they met and mixed with the local Neanderthal populations. This wasn't a single event, but a long process of interaction over thousands of years. While this gene flow has preserved the Neanderthal legacy within us, it may have also contributed to their disappearance as a distinct population. If a small, struggling Neanderthal group was consistently mixing with a larger, growing population of modern humans, over many generations their unique genetic signature would simply be absorbed and diluted into the larger gene pool. It wasn't a replacement. It was an assimilation. They didn't just vanish, they were swallowed by our expanding population. In the end, it was likely a perfect storm of factors: a brutal and unstable climate, dwindling genetic diversity from living in small, isolated groups, and finally, competition and absorption by the waves of modern humans moving into their territories. They didn't go out with a bang, but with a slow fade, their flame gradually flickering out as their genes were carried forward in a new kind of human. If we carry their genes, can we truly say they are gone? Or are we just the latest version of them? Let us know your thoughts below. And if you want to unravel more mysteries of our ancient past, make sure to like and subscribe.